Okay, so this is about swap colors, and the idea was to put red to green, green to blue, and blue to red. So what does this student do? You go through all of your pixels, you grab the pixel, you separate out the red, green, and blue, and then to red. Oh, except that this is a problem. This will change the red to green, the green to blue, but red has already been changed to green, and so now red is destroyed, and blue is going to be well, replaced with something like the green. Not only that, but with swap colors, you didn't need to invert the colors. So how are we going to do this if we can't just replace the red, green, and blue? Well, it's actually a lot easier than we think. We don't even need to do any calculations in R, G, and B. This, in our new pixel, is going to indicate the red value, and so we want to put red to green. So we want to take and put green in the red, put green to blue. Okay, we want to store our old blue value in the new green location, and put blue to red. And so we want to store red in the new blue location. And we're done. It's really that easy. We just need to just swap around the locations of the R, G, and B inside of this. And notice that as soon as you make an assignment to a variable, you have now lost what was previously stored. So if you're trying to use what was previously stored in it in some later line of code, you have to make sure that you save it out to some temporary spot. If I wanted to alter the R, G, and B values, I would have to have something like int temp equals R, and then I can rotate R equals G, and then G equals B, and then I can say B equals temp. I can't say B equals red down here because red was destroyed up here, but if the old red value was set aside, stored in some temporary place, then when I get down here, it's still safe because it didn't get destroyed in this assignment. So that's how you would do it if you were going to leave this as an R, this is a G, and this is a B. But you don't even really need that in this case. So that's how you would do that. Let's go ahead and run it and see what happens. Swap colors. And the real test for this is if we swap colors 3 times, there's still a problem. Am I running the right code? That's always the question. Now I'm looking at this one. That wasn't from project 3. That was project 15. And so swap colors, that's once, that's twice. With luck, 3 times we got back to the original. Okay, so that's the real test to see whether it works or not. If I left this back with the original thing, I believe that's the original, and we run it, we're going to get some changes in the colors for sure, but it's not swapping them. Yeah, that looks cool. It's kind of psychedelic. Can I do it 3 times? No, because I lost some data. I can absolutely guarantee that if you keep doing this, you'll never get back to the original, although it is pretty cool. I like the effect. We may be cycling through something at this point where we may not continue. So this is kind of blue and red. This is blue and yellow. This is a blue and red, but it's not the blue and red. Okay. That's a blue and yellow, but it's not the... Yeah, if I swap enough times, I eventually get back, but we have lost some of the original information, so we'll never get back to the original image. Once you've lost it, because of the funky pattern here, you may not lose any further information, but you do lose one of your color values. And in fact, the one that you're going to lose right off the bat is your original red. It'll be gone. So let's see, who else? Let's just backtrack through these. Swap colors. This one, what does it do? Splits out the red, green, and blue. Okay, so this just did the assignment without the inversion, so it's not going to look quite as funky when I run it, but it's going to lose some information. So if I swap colors, that looks okay. Swap colors again, that kind of looks okay, but okay, I'm running the wrong one again. Run it twice, run it 3 times. I don't get back to the original. Now that looks sort of like the original, except if we reopen the original, we'll notice that the green is sort of changed a bit. We in fact lost one of the color values. It might be more prominent if we start out with a black and white. Swap, maybe not. Black and white isn't going to do anything with colors. So if you open the original and you look at this green, it's a little bit of a gray green, and this is white with maybe a little bit of a blue-gray tint to it. We swap colors, swap colors. Now it's a little bit of a purplish tint, and there's no grayish in this. This is more of a blue-green. And so you're always going to get back to this blue-green now because you've lost one of your color values. So that doesn't quite work. And I think it's the same problem repeated. Yeah, it's exactly the same problem in this student, so there's no point in going through that again. And exactly the same problem again here. So you just got to be really careful. When you do this first assignment, you've lost a little bit of information. Once you lose that information, you can never get it back. And so this isn't a true swap of colors. You end up with the same value in both red and blue instead of rotating your colors as we had wanted to. Okay, so that concludes this video. I guess the next thing will be invert and then lighten and darken.